All right, my name is Shane Cravins, and I'm the Chief Architect for NDAS. And today we're going to talk about our peer review tool. And it started kind of last year at GDevCon, where everyone was talking about open source. So I went back and went to my NASA team and said, what can we do to kind of go down that road? So this is our first venture down the open source path there. And we did our peer review tool, which is nice and just consolidated. It's not part of our baseline. So kind of just going down that road there. So a little bit about NDAS. It's a group of 6 or 7 developers that we have. I've been working on this project for over 10 years. It's all LabVIEW based, actor framework, heavily actor framework, modular pieces, and see down at the bottom there we have a gimbling of the RS-25 engine using Compact Rio for that. All that is actor framework as well. So we're really proud of our NDAS platform there. And so like I said, the goal is to eventually get to the point where we can open source a lot of these individual pieces and all, but today we're here to talk about the peer review tool, which is what we use to review our different applications. And so why do we need a peer review tool? Well, originally we had the old way of just using the git log and going and doing a diff of every file, those type things there. It's slow. All files are treated equally, and if you have like a type def and you modify a type def, you'll see propagations that aren't necessarily changes. So those are things that we've just kind of dealt with, and I don't know if you've ever seen the error there, but sometimes if you try to do a LV compare, you'll see that there. So with that, we created the peer review tool, and it was the first NASA Stennis open software, so we're proud of that there. All right, so for this example, I just added a new field to the cluster, and I created a new VI to just toggle the field. So in the old way of doing a review, we would go through, and the reviewers for the peer review would go and manually go look at each one of these files and go and see what changes were there. And in the new way, I'm going to run some code here. So we're going to run the peer review tool with that and see what it does. So what I'm going to do is run the peer review tool, and it doesn't have a lot of showiness, whatever. It was kind of built as an internal tool, and we're just kind of steadily growing there. It's on GitHub, and I'll provide the link in a little bit if you want to download it, play with it. But what it'll do is you can do git pull from here. You can do a review branch, and what that's going to do is we use it 2 ways. We can do a pre-review before you do a push to do a commit, and that'll review things. As the developer, you should do that. And that's what I'm going to do here. So I made changes locally on my branch, and we're going to review that there. So if I hit review branch, it's going to come up and say there's 18 files that are modified. Do you want to include those in a review or not? So I'm going to hit yes. And it allows you, the peer review tool, to resume a review from previous. So if you wanted to, say you have a 500 file review, you could review half of it, come back later. So it'll resume that. But for this, I'm going to just say new. So it's going to show the 18 files that are modified there, and now it's going to go through and do interrogation of which ones actually modified. So you quickly see, of the 18 files, there's only really 3 files that have been modified for this. Now it's going to go through the VI analyzer. We have 50 tests that we're interested in from our baseline standpoint, so it's going to go through those and do a VI analyzer check and see if there's any issues of those 50 tests per each LabVIEW file. And you'll see we have one finding there, so it's wires under object. So if we go look at it there, you'll see that the developer accidentally wired around the in place. So that just kind of showing VI Analyzer finding an issue there. So if we go back over here, so we're going to close this. And if you ever want to come back, you can run VI Analyzer for the whole suite of files, or you can right-click and run Analyzer for one specific file. So we're going to go through, and you'll see right now there's 3 files that the reviewer needs to review. And down there it says 3 files ready to review. So if I double-click, since there's not a file to compare against, it's a new file, it's just going to show you the file. And if we go this, it'll bring up the tortoise diff to show you any text-based files. It'll show you the difference between what's in master and what's in the current file there. So you'll see I added toggle new field. And that's the change there to a new field. I added that just to kind of show something going on there. So like I said, it's really helpful for us, and kind of the end goal is I want more people to use this, just to kind of get feedback and collaborate and help us go down the road of making more of our NASA software open source. So, all right. There's a lot of right-click functions there. And so, like I said, if you want to help, I'd love it. And the QR code is right there. And if you want to talk more, I love talking about all things LabVIEW and all things peer review. So, go ahead.
Is that list of file changes, is that taken from Git?
Yes.
Okay.
Yeah, it'll do the Git untracked changes, and that's what triggers that initial pop-up there.
And so it's wrapping the Git command line client?
Yeah, that's right.
Awesome.
So, guess go ahead.
Is every single change reviewed by somebody other than the developer
Yes.
in your organization?
Yes, absolutely. Yeah, every file is reviewed. So, and that's what makes it difficult. We have PRs that end up being 500 files big, so it's hard for somebody to go through and do that. So this helps focus the attention on the files that are actually modified. And I'll go back here to show, didn't really talk about it too much, but we have a lot of columns that are applicable to us here. So the revision, so this will essentially tell you, like, why did it take the developer 50 revisions in this one PR and those type things there. So it kind of helps us flag things. We like all of our front panel and block diagrams to be in the 1920 by 1080. So we have fields there specific for that. Cyclomatic complexity is really important from a NASA standpoint. So we like to have things that are applicable to us. So, all right. I think that's it. So.